Fantastic. So yeah, it's great to be here. I've attended a lot of React meetups in Pune. That's where I'm from. But this is something amazing. I mean, I didn't expect to be presenting in front of this large of a crowd, but it feels good to be here. A quick intro. I'm Harshil. I am the director of front end engineering for Velocio Technologies. We're engineering partners with largely Bay Area startups, and we recently got acquired by a large company called our Systems. So now we're working with enterprises. We do full stack development. We have our business units for cloud, DevOps, data engineering, QA, and media services. So that's a very two-liner brief of what we do. But what we do is we just write kick-ass code and build awesome products for startups and enterprises. So, what am I going to talk about here today is multi-threading in React. Now, I mean, a lot of you all, when you must have read the name of the topic, you all will have been confused that okay, hey, multi-threading on the front end. And I mean, a lot of you all know that okay, how that works. Like theoretically, we've read about web workers and service workers and whatnot, right? But to what scale in our day-to-day development are these uh, browser offerings that are offered? Sorry, yeah. So, on what scale are these browser offerings going to be good for us, right? How much can we utilize these in our day-to-day development? Sorry, am I hello? Yeah. So, on what scale are we supposed to utilize these day-to-day? Yeah, better. So on what, I mean, how much can we actually utilize these browser offerings in our day-to-day front-end engineering, and how that just elevates and eliminates a lot of issues and elevates our issues that we face. So by a quick show of hands, not only on production, but let's say you wrote a piece of code and you ran it, and it just your browser just stood there. It became non-interactive. It didn't work. The code hanged. How many of you all have faced that? You wrote a piece of code. Could be anything. You just wrote a set state, which is like recursively called. You didn't write your fed hooks right and all of that, right? So we've all faced that issue, right? And this is what we're trying to address, right? Where we're trying to really capture the power of the browser to try and elevate and eliminate these issues. So yeah, just a quick overview of what we're going to be talking about. That multi-threading in web development of I mean, how traditionally a single-threaded JavaScript execution works, which we all know, but in context of what we're going to talk about, how does that work, right? What are the challenges that we face in client-side processing, right? I mean, now that browsers are so much more powerful and you have a lot of logic that the browser is running, right? So in that case, what are the challenges that we face in building our day-to-day regular products? And then the introduction of web workers and how web workers are supposed to work in tandem with React to actually solve the problems that we're trying to address with these client-side processing. And then we'll just do a quick demo. So yeah, I think about 10 years back, or maybe even 15 years back, when jQuery and your Backbone JS and all of these came out, it was a huge change in how web apps are made, right? Because now the community had really started to harness the power of the client, the browser, right? So single page applications really took off, right? And then a substantial amount of the computation, or any kind of business logic processing, that shifted on the client, right? So what did this was, it just saved you a lot of round trips to the server, and just elevated the experience of using JavaScript on the front end, and having your logic, a lot of logic on the front end. But at the same time, what did this was it increased the demand for better ways of processing on the client, right? On the back end, we must have heard so many different ways of writing optimized business code, trying to optimize your computational time and all of that, right? But that's never happened on the browser. We've never thought of optimizing workflows and business logic processing on the client, which now it's more than important to try and do that, right? So, I mean, JavaScript is single threaded. We all know that, right? I mean, we start writing our loops. We start you know rendering our charts and all of that, and we know that there's a single thread which is taking care of all of this. It may be really fast, it may be really optimized, but at some point when you're doing a large amount of processing, it will cause bottlenecks. And I'm pretty sure, we've all faced that. The UI is freezing because, suddenly you didn't expect a surge of a very large array that your function is supposed to process on the client, and a surge of data has come and your UI just froze, right? So these are very, very common issues that we face in day-to-day interaction. So, I'll come to some good examples that will help us understand how this works. Challenges in client side processing. Just repeating myself that, uh, you have some long running tasks, right? You have some tasks which need a lot of processing, and it could be a simple function which accepts a very large data set and converts it into a chart friendly format that you want to render a time series or whatnot, right? So in that case, it simple things like these just they freeze your UI because you're not expecting that surge of data. And not only does it freeze your UI, but also it renders the other areas of your application. You have navigation bars on the top, at the left you have some footer links or whatnot. They all go, they're non-interactive now, because your single thread, your main thread, is actually blocked by some very unexpected large processing task, right? And that's what we're trying to solve here through multi-threading, and we'll come to how, right? So a good example is, like I said, you want to build interactive visualizations, and when you're building interactive visualizations, you can't expect that, hey, you know what, I'm going to build an interactive visualization with a certain amount of data. I mean, you know your charting libraries these days, they are so powerful that they allow you to plot tens and thousands of data points, and it's still, I mean, the actual rendering process of it is actually very good, right? I mean, these days there are canvas-based charts that have evolved from SVG charts and all of that, right? So in that case, it's charting libraries have really come along to help you plot this data, right? But on the contrary, the compute of the browsers. So I mean, let's say you're pulling, you want to plot data for 20 years, 25, 30 years. It very normal use cases if you're, building maybe a stock market application, you just want to trying to study some historical data, plot over that involves a large amount of data set to be plotted, right? So then the questions come like, hey, how do we handle this? Hey, you know what, let's just do some caching on the back end. Let's just fetch some data. Let's fetch the data incrementally. And there's a lot of how do I put this, there's a lot of hacks involved when you try to do this, which doesn't necessarily, or it actually never considers the UX of how it will look, right? I mean, let's say you're studying data of Infosys as a stock over the last 20 years, right? You wouldn't want to click on the left or the right buttons to, oh, okay, you know what, I'll click on the right button to get another 10 years of data and all of that. I'm just giving an example. So, you know, uh, that having said that, the compute of the browsers really falls short, right? Because uh, so this is high charts, right? So high charts expects your data to be in a certain format. Now the data that comes in from the back end, that doesn't necessarily need to be in the format that the chart expects, right? So very basic use case is, I'll write a function that accepts some kind of a data from some kind of a source, and massage that data, process that data, and feed it to the chart, right? Now sounds simple, but when you try to do that for tens and thousands of points, tens and thousands of data points, your main thread will get frozen. And even though the charting library is really great, but your main thread gets frozen, and for a few seconds, it just freezes the UI. So and again, like I said, moving this process to the server is a chicken and egg situation, right? Because at the end of the day, you will fetch all of that data points, even if the processing moves to the server, right? So that's one example. Another one is a very, very common example: image processing in the client, right? I mean, uh, you know, let's say you're building an application, and your application has a very trivial feature to it where you can just edit an image. could be the brightness, contrast, resizing, cropping, all of that, right? But when you start dealing with really high resolution images, right? uh, there's a good chance that you've written a lot of really good code to do that processing of, hey, this is the function that runs on resize, this is the function that runs on click, this is the function that runs when I change the tool, right? Now all of these functions are now dependent on the processing power or the compute of the server or their network or the network of the client, to be able to do these if you shift all of that logic on the server, right? Which just doesn't seem right. I mean, imagine you're trying to change the brightness, you move your brightness bar, you put your brightness toggle, and it takes a few seconds for the brightness to actually show up. That's a really bad experience, right? So, in these cases as well, where a lot of logic on the client, which is absolutely unavoidable to put it on the server, you have to put it on the client. In these cases as well, there are the freezing and the bottle performance bottleneck issues really come up, right? So how do we solve this? Now, web workers. Now, I mean, I don't know how many of you all have heard about the web worker API. Just heard, never worked with it. So okay, so there's a large crowd. Awesome. So now by definition, web workers allow you to spawn a thread, spawn a worker thread, as they like to call it, that can run background tasks, right? And just, I mean, I'm just going to give a quick brief for the people who haven't. It just spawns a worker thread, and the worker thread doesn't have the context of the main thread. The main thread is actually have the context of the current window object and all of that, but the worker thread has none of it. It is just purely made to run background tasks, right? I mean, no DOM manipulations or no rendering related stuffs, nothing the worker thread can do. But the worker thread can, the advantage it has is its own separate execution thread, right? Um, and the communication between the main and the worker thread happens through a very nice message passing, through message passing, right? And the worker thread at the same time also has access to other browser APIs that help. I mean, other browser APIs that help with these heavy computations that you do on the browser, like IndexedDB is an example, or WebSockets are an example, right? These technologies that the browser provides are really great for in tandem to work with your worker threads to create a very nice client side computational, heavy computational processing workflow, right? So these are what web workers do. Now coming to React. So yeah, I mean, we know what web workers are. We saw what the problem is with client-side processing, and we're all here for a React meetup, right? So how does this work with React? So I don't know. I mean, 10 years back, or even right now, 10 years back, the notion behind React to be launched and this adoption that React has had in the last 10 odd years is because it's a view library, right? I mean, what it did was it allowed you to write your interfaces in a declarative manner, right? It runs on the concept that, hey, you know what? Let the manipulation of the DOM or the rendering logic move to memory. Let the memory, like a virtual DOM, take care of that, right? So this only goes to show that React is extremely optimized. React is extremely, considered or made with the consideration that it will heavily optimize your view or your rendering workflows, right? You want to render a large list. You want to have a very good experience about rendering a nav bar, which quickly changes your paths every time you try to switch to a different screen, right? So all of this rendering based, view based logic is what React is optimized for and continues to optimize for these. But as developers, we generally try to mix two worlds. We try to mix the view world of React with the data and the business logic world of the client. We try to mix those. I mean, I don't know how many of y'all have written very heavy for loops in your on click handlers, right? A lot of people might have, you've written some good heavy for loops in your on click handlers because you're like, hey, you know what? React is extremely performance optimized, but it's not performance optimized for business related workflows, performance optimized for view, right? So we do that, and what it leads to is a laggy user experience. And then we also try to optimize these laggy user experiences by optimizing React, which is again like a, it's anti-pattern, because that's not what optimization. Okay, you try to memoize some of your data, you try to create your callbacks that don't get fired again and again, you try to optimize your effect hooks without realizing that a lot of this what performance bottlenecks are actually happening through because of because of a very large amount of client side processing in general, right? So this is where web workers come in, right? Web workers can actually act as the controller, as the business logic layer, and let React just focus on the view parts of everything, right? And that's where I mean, and this whole harmony where the business logic and the processing is happening in the web worker in a separate thread and React taking care of the view, this harmony is what can really elevate good user experiences. And that's what we're here for, right? We're trying to really elevate UX for the people who use our products, right? So yeah, I mean, okay, so some good real world examples for where web workers are actually used. So, I mean, these are very common names, right? And so Google uses for processing large geospatial data, route calculations, and all of that. Because I mean, I'm pretty sure we've all used offline Google Maps, right? How does that work? How do they do the processing even when they're not connected, even when our devices are not connected? That's web workers do that on the browser. Facebook does it for some background sync. Dropbox actually utilizes it for when you want to process a large file for upload. Twitter for real-time data stream. Slack does it for like background sync of their jobs, right? Figma, and I haven't had one example here, but I'm pretty sure we all use Linear, right? And I mean, Linear as an app is extremely great UX, right? I mean, and what they do is we all know. I mean, if you all have read about Linear caches all of their data that you see on the client IndexedDB, right? So it uses employees, web workers to actually keep that IndexedDB in sync with what's on the remote, right? So these are a few good examples. And apart from these examples, these are just some regular good old use cases that I'm pretty sure a lot of y'all who are building products on a day-to-day basis can actually relate to, right? So some good use cases are you can do some good Excel file processing, right? So you upload an Excel file which has tens and thousands of rows of data, and you want to do some you know do some processing with that data of an Excel file. You want to maybe just send it to a server. You want to maybe, in fact, you can actually do a lot of Excel file processing that generally happens on the server, where you scan the Excel file, and you want to change the data and export it to another Excel file, right? Charting middleware, which I spoke about. Background cache syncs, again, what Linear does, right? Handling real-time data. So this is a good one. So like I said earlier, web workers actually work in tandem with web sockets, right? So in imagine a stock market application, right, where you're getting a large stream of data through your WebSockets every microsecond. Actually, every millisecond you're getting tons of data, and you want to do that processing on the client, maybe feed it to a chart or whatnot, right? So all of that, you can have a web worker doesn't block your main thread to do that. And like Dropbox does, processing a large file for upload, you don't need to be a storage technology to process a large file or upload, right? You can very well be a healthcare application who's accepting a large CSV of patient data that you want to upload to your system, right? So it could be as simple as that. So these are some just regular, good old use cases, right? Um, okay, so I'm going to give a quick demo about, we're going to try to render a large data table, and we're going to do the filtering of that data table on the client, right, with large number of records with no route trips to the server, right? So I'm going to stop sharing, and just going to quickly share my code. Oops. Okay. So, I have this component, right? It's a Vue.js app. It's using ShadCN for UI, and yeah. So what I'm doing is I'm just rendering a table here with a large amount of data, right? And what's happening here is the filtering happening, the filtering that's happening on the client is happens on search, right? So let me actually stop sharing and share the UI first. That'll be better. Uh, just a second. Oops. Okay. Yeah, we're good now. Stop share. Share screen. Okay, so let's say you are looking at a transaction history of some some person. Let's assume this is Stripe, and you're looking at transaction history for the last, I don't know, 50 years. I don't know. I'm just gonna think about a large data set, right? And what this does is we're gonna try and do some searching, and this searching happens across all the columns, right? So like for example, if I search for 783, which is the first entry, right? So that's gonna uh, do a very quick search across, I'd say about 2000 records and return these results, right? So I'm not sure if you're seeing this, but every time I type, there's a small loader that's seen here. So if I'm going to type something, there's a small loader that's seen here, right? So this loader is actually the main thread waiting for the web worker to get back with the filtered data, right? Okay, good. But what about it? If like imagine having this filtering logic on the client without web workers. Every time you see the loader, you can expect that your UI is going to get frozen, right? And I'm on a Mac, and it's a good laptop, and imagine this on Windows machines of our customers who have really low, very old machines, right? So they're going to start facing that lag. So this loaders is actually your main thread waiting for the other thread to return the results, right? um okay, so this is the app, right? This is a quick example. Now, going to the code, quick, uh, yeah, so this is the code. What we've done is a simple, we spawned a new worker here. So this is the syntax for spawning a new worker, right? Um, and I mean, there are different types of web workers, there's shared workers, but that's a talk for another day. But we what we do is, every time the search query changes, we send the worker the overall data, and we also send the search query. And on getting the message from the worker, we're just going to call a couple of set state and toggle the loading states. And the actual worker is this is how it looks like. It's going to filter some data, right? So very, very small example, might not do justice of how much you can utilize web workers, but imagine a small scale, imagine your data grid with 100,000 records, and you're trying to filter this, right? You want to create client side filters. So, okay. So yeah, I think yeah, that's a small peek at the code, right? So I'm going to open source this and, share you all the links so that you can go like a quick look at it. And